Hey guys, so today I'm going to talk about uh, logical proofs and what exactly a logical proof is, what they're supposed to accomplish, and how. So, a logical proof is basically, if you take any argument, let's say I say, well, if it's raining, then it'll be wet outside. If it's wet outside, you gotta bring your umbrella. Well, it's raining, therefore you should bring your umbrella. When we make arguments like that, the arguments work because they follow certain rules, right? And when we formulate these arguments and when we know that they work, we're usually not aware of the rules that we're applying, right? And a logical proof is supposed to show us step by step the rules which allow an argument to work. Okay. And so basically, any logical argument is going to, any valid logical argument is going to use a collection of rules to prove a conclusion, right? This is what all logical arguments by definition strive to do. So basically, a logical proof is just showing you step by step a justification for how the conclusion follows from the premises. Okay, so we can start with the example that I just mentioned, right? If it is raining, then it is wet. If it is wet, then we should bring an umbrella. It is raining. Therefore, we should bring an umbrella. Um, Now, just throwing this out there, some logicians might not uh, like this argument because it has a should statement, but you don't have to worry about that. That is something that only a logician would really care about. Let's look at this argument, though, right? It seems valid, right? Because it seems like the conclusion follows from the premises, right? The premises here are if it is raining, then it is wet. If it is wet, then we should bring in an umbrella. It is raining, right? Those are the three premises, and the conclusion is we should bring an umbrella. Okay, so let's go through and put some variables in. We have R for it is raining. I have W for it is wet. And let's put U for we should bring an umbrella. Okay. Um, Now we can reconstruct this argument in logical form, right? So if R, then W, if W, then U, R, therefore U, right? So a logical argument basically allows us to prove that we can get U from these three premises, okay? Now remember, you have to apply rules, and the rules have to be applied in certain ways, right? There's only one way in which, sometimes two, in which each rule can be applied, right? So what you need to do first off is you need to memorize or take notes of when each rule can be applied and what it does. Okay. So in this video, I'm really only going to talk about three rules. Okay. Now those rules are going to be conditional elimination. Okay. So this basically this rule says that if you have a conditional statement, say the if and if R then W, then you can eliminate the conditional to just get the antecedent, right? There is also a conjunction introduction, and there is a conjunction elimination. So what a conjunction introduction does basically is it allows you to take two different atomic parts and put them together with a conjunction, right? So if you have A and you have B as two premises, then you could use the conjunction introduction to make it A and B. Okay, that's why it's called conjunction introduction. It's very self-explanatory. Now, the other rule is conjunction elimination. So if you have A and B, you can eliminate the conjunction to say either A or B, right? So basically uh, all of these rules, by the way, have multiple names. So I'm just using these really simple names. You know, people have been doing logic for a while, right? And people note like have different notations, different names for things, but it all pretty much works the same way. Now, there's different styles of logic. So there's sentential logic, propositional logic. We're only caring about sentential logic right now, which is the most simple. And that's what we've been doing for the course so far. So let's prove this argument. Okay, so let's say the first premise, so what we want to do in a proof is number the premises. Okay, if R then W, so that's the first premise. The second premise is if W then U, and the third premise is R. Okay, so how do we do this? Okay, well, first off, I should say, just remind myself these three things are premises, right? They don't need rules applied to them. We already know them to be true, okay? However, after this, right, we have to use logical rules to derive the next steps, okay? So a conditional elimination allows you to bring together a conditional, like if R then W, with an affirmation of the antecedent, which in this case would be R, right? So if R then W, if it rains and it's wet, well, you know, if you have a second premise that says, well, it rains, then you know that it's going to be wet, right? So we can put W here. And we put W here, and we need to cite the specific rule first. The rule is, as I said, conditional elimination, right? Can't put any other rule there. You can only put the appropriate rule that works the way you want it to operate, right? And then you want to cite the lines that you use. So here we use lines 1 and line 3, right? Because here we have if R then W, and then 3 is R. So we can bring these two together to prove W, okay? Next, we can prove U, also using a conditional elimination, right? Except this time we're citing lines 2 and 4, okay? Now look, U is the conclusion that we're trying to prove, right? U is we should bring an umbrella, okay? Well, that's exactly what we're trying to prove, okay? So this is the conclusion. We have now proven this argument, right? We've proven that it's valid. We've proven you can derive this conclusion from the premises, okay? So I'm just going to quickly go over two other examples that use these conjunction rules, right? So the first one would be a conjunction introduction. It works pretty simply. Okay, let's say you have A and you have B. Okay, these are your two premises, right? The conjunction introduction would look like this. You would say A and B. Okay, and this is a conjunction introduction. Okay. Um, Now I could be kind of silly and I could, oh, I still have to cite the lines, right? So this cites lines 1 and 2, right? Now I could, going on to the next page, I see. I could, in fact, make this A and A and B with another conjunction introduction, right? I'm literally introducing a new conjunction, right? That's why we call it a conjunction introduction, okay? Because you're literally just installing a new conjunction, right? And when you put in a new conjunction, you need to already have the particular values known, right? So here we know both A and B, okay? And because of that, we can install a conjunction between them, right? Now, if we know A and we know A and B, then we can install a conjunction between them, right? And in fact, we could keep going forever. Okay, so we can make this B and, oops, I messed that up. B and A and A and B. Okay, and this would be a conjunction introduction on um, lines 2 and 4, right? And in fact, I could go even crazier, right? I could make this A and B and B and A and A and B. Put another parentheses here. It's good when you have lots of parentheses to just keep track of your parentheses, right? Parentheses are really important to get right, okay? And so here we are conjoining 3 and 5, right? Um, okay. So once again, just to review, each time you use a rule, right, you need to cite the rule. Now, and you can only use the rule on lines where it's appropriate, right? And you can only use the rule to produce something that's appropriate. So here we are literally introducing a conjunction, right? I can't use conjunction introduction to do anything except a conjunction, right? And I can only ever conjoin two things that I already know, okay? Now I just want to quickly do in the other way. Okay, so we have, as well as conjunction introduction, we also have conjunction elimination, right? Which is exactly what it sounds like. Take a conjunction, say A and B, and you take away the conjunction, right? And that would be line 1. Okay, so I can derive A from if A then B. Sorry, not if. So I could derive A from A and B. Okay, and that should be kind of obvious, right? Like if there's a cat and a dog in the room, I know that there is a dog in the room, right? This is one of the more simple logical procedures our brain can make, right? Is the conjunction, elimination, and introduction. Okay, now I've got A, I can also get B, right? Now it's important to note that right? I used conjunction elimination here to get A and here to get B separately, right? You need to do these separately because each line needs to be a self-contained logical statement, right? And now, in fact, what's kind of fun is I can make B and A, right? Using 2 and 3 with the conjunction introduction, right? So that's kind of how these rules work. Okay. I'll just quickly review it right here. We translate this argument, okay, just the way we always would, right, into this. And then we list the premises, 1, 2, 3, and then go through step by step and apply the rules until we get the conclusion, right? Same thing here. Okay, so I hope that video was helpful. I'm going to be releasing more shortly. Thank you a bunch, guys, and good luck.